Hello everyone, welcome to this video. We are going to talk about perceptrons, also called nodes or neurons, but for this video, we will call them perceptrons. So if you remember this diagram of deep learning training at a high level, perceptrons fit into these three components: inputs, weights, and then outputs. Here is a diagram of a perceptron, and here's the logic being run. Number one, multiply the inputs with matching weights, sum them up, then add the bias. So here we do x1 times weight 1, x2 times weight 2, plus x3 times weight 3, plus the bias. Then input the sum into an activation function to get an output. And this activation function we can customize to be whatever we want. Here, I will do something pretty easy to understand. If the sum is greater than 0, output the sum, else output 0. So the output will always be sum or 0. So if our sum is 1,000, then the output will be 1,000. If the sum is -10, then the output will be 0. Let's go with a more real-life world example, although a bit contrived. Determine dog adoptability. Notice that instead of x1, x2, x3, we now have age, height, breed. Instead of w1, w2, w3, I inserted completely random numbers for the weights. And I did the same thing for the bias. I just set to 0.04. So determine dog adoptability. Sum equals age times 0.1 plus height times 0.3 plus breed times 0.5 plus 0.04. Input the sum into the sigmoid activation function to get an output from 0 to 1. So as this text says, for the sigmoid activation function, we will always get an output from 0 to 1, which can be very, very useful because if we get 0.5 back, we can think of that as 50%. If we get 0.6 back, we can think of that as 60%. Now, where the output is how likely the dog will be adopted within the next 12 months. So an output of 0.9 means there is a 90% chance the dog will be adopted within the next 12 months. Let's actually code a perceptron. You will want to download the perceptron.ipynd file from the GitHub course repository, upload it to Google Colab, and for this, we do not need a GPU. A CPU will be just fine. And I just copied this picture and this text from the slides. Let's actually go over the perceptron code. For inputs, I did 1, 2, 3. You could imagine, right? Age, height, and breed. So maybe the 1 means 1 year old, 2 means a height of 2 feet, and 3 means a breed of Chihuahua. Use your imagination. We have weights that's also 3 numbers long because inputs with matching weights. We have 3 inputs, then we have 3 matching weights. I'll set the sum to be 0 and a bias term of 10. Although this can be any number you want. Here I made it 0.04 in the slide, but here I make it 10 just to make the math a bit easier to understand. For the activation function, we are not using sigmoid. I'll just use my more simplistic activation function of if sum is greater than 0, return the sum, otherwise return 0. And then this for loop, well, it multiplies the inputs with the matching weights and sums them up. So this is 1 times 2 plus 2 times 4 plus 3 times 6. 2 plus 8 is 10. 10 plus 18 is 28. 28 plus 10 is 38. And here I do a print statement, and it is 38. And after we pass 38 to the activation function, we get 38 back, which is expected. However, let's make the sum negative. So I'll make the inputs negative numbers, And we get a sum before the activation function of -18, which returns a 0 as expected. Okay, cool. You now know how perceptrons work, and I will see you all in the next video.